Gisle.
So let's start. My name is Gisle. I've been with ActiveState for yeah. I've been with ActiveState for more than 10 years now. And I've mostly been doing Python. No, mostly been doing Perl stuff. For the last few years, I kind of found myself doing more and more Python stuff. And nowadays, I would say that about 80% of the things I do is Python related. While kind of all the people in the company actually is located in Canada, I'm the sole person outside, and I'm actually located where this nice blue plants actually live. I'm in the beautiful city of Bergen in Norway. For the last 2 years, I also kind of started working for the university there, so I'm kind of part-time ActiveState, part-time university. At the university, I manage our website there, which is a big OP-based CMS, which is something very specific to us in a way. And I try to kind of promote Django all the time instead of trying to get rid of this. If you look at the program, you will see that this talk is actually supposed to be by Diane Miller. She's our product manager at ActiveState. But unfortunately, she couldn't be here. And they found that I was pretty close and asked me to go and give this talk. This is kind of partly kind of her kind of talk, so see if I can manage to get through. So the things I'll talk about is say a few words about ActiveState, the company. Tell you what we mean by the cloud. Give a few examples of Python in the cloud. Tell you about how ActiveState become kind of evolving cloud work and what our experience with that is. What we think are good ways to approach the cloud. And then if there is still time, I will get into kind of our kind of product that we are kind of pushing these days or released as a developer preview actually this week. So it's called Staccato. So ActiveState, it was founded in 1997. Initially, we focused on code for Windows and supporting that very well. We very soon branched out to Python, and we built our IDE, which is called Komodo on Python. IDE on Python, so it's very good for Python stuff. We have a lot of users and companies that actually use the software we do. I'm not exactly sure how we came up with this number, but it seems pretty impressive. We provide solutions for developing, to manage things to develop, and for distributing stuff. We need to kind of distribute it with the runtime for the language itself. We have 3 languages which we call core languages, which we support better than the rest, which is Python, Perl, and Tcl. Core meaning that we have extended support for them and that we provide our own distribution for these languages. We also support all the dynamic languages in our IDEs and cloud thing. Komodo, it's already integrated to our environment. And Staccato is another product we push. And Staccato that's the same. It's tagline is there. Cloud. We do the right thing. Cloud. So it's a bit fuzzy concept, so can we make it less fussy and define it? Luckily, there is somebody that has come to the rescue here. It's called NIST, which is the National Institute for Standards and Technology. It's a US agency that has come up with this definition that people seem to agree that this is a good way of kind of talking about cloud computing. So I thought I will kind of go through it now. The definition is in 3 parts. The first part is talking about kind of the essential premise for cloud computing, the characteristics that make something be cloud computing. First one is on-demand service, meaning that you should be able to obtain this service without having to interact with any humans from the service provider. Usually this can be through some web interface, but usually you also want API, so you can also eliminate the human on the consumer side. Broad network access, it means that the service should be available on the network using standard mechanisms. It means that the service should be available on the web or HTTP. Source pooling. It means that the cloud provider kind of serves a lot of clients and they kind of share the resources underneath. Dynamically allocating them between the customers and then operate on a scale, which makes kind of things it makes it cheap and it makes it possible to kind of give the impression that you have much more capacity than you actually have. Rapid elasticity means that you can easily scale up and down as you need to go up and down. And measured service meaning that the resources that you use are limited at some level, and that both the provider and the consumer can kind of keep track of what's used and stuff like that. Next part of the definition is about the service models involved in the cloud. Here you have these 3 famous acronyms: IaaS, PaaS, SaaS. Infrastructure as a service, that's when what's provided is basically machines that you put your operating system on and off you go. Basically, Amazon, EC2 services, this kind of thing. Platform as a service means that the cloud provider is kind of taking care of everything with machines and middleware databases and making it all work underneath. Typical examples here would be Google App Engine. Software as a service is kind of where everything is provided by the provider, and you just access the apps directly from the network as a consumer. And software as a service, typical examples could be Gmail, Google Docs, Salesforce is also a typical example. And the last part of the definition is different deployment models. Private cloud meaning that all the infrastructure is on-premise in a single organization, owned by that organization. Community cloud is where a few organizations that share some common concern go together to have a cloud together. And public cloud is where kind of the cloud service is provided to the public at large. Kind of the Amazon model. And hybrid cloud is when you kind of mix and match. You might have an application that's part of it lives in your private cloud, parts of it lives outside in the public. So you might, for instance, want to keep your data in private cloud so it doesn't escape for some reason. And hybrid cloud, and use the public cloud to scale up where you do that. Just funny cartoon. Kids take on the cloud. So oops. Describe this. It also highlights kind of unreliable cloud mining. So it might make sense to compensate for that and write your stuff in a way that makes it possible to deal with the fact that the cloud might not always be as reliable as having machines directly on. slide shows various technologies that are often involved when Python is used in the cloud. Django is kind of a big part of it, and often kind of puts premises on how people do this kind of thing. And there is a lot of activity in this case that kind of makes various offerings show up. So see what happens. There seems to be a lot of private betas of things you can try to host your Django app in a public cloud. So that's it. What is that? Okay. Here. This slide just shows a lot of examples of kind of things, sites that actually use Python out of the cloud. I don't think I will not go into this because I don't really know that much about what things these are. I have also here would kind of go on about this. So I'll go into how we can get got into the cloud thing. It started by a Firefly project that we did about 2 years ago. It was a cloud-hosted project management and collaboration site, a place where you could host your project, both private and public project, host your code, track bugs, and your project, host your documentation. It's kind of similar, and it competed with GitHub in a way. So the problem with this was that it didn't actually get the traction we needed to keep it going. So we ended up decommissioning it. But we learned a lot about building this kind of app without doing this. The system was based on Track, this Python thing. And yeah, we did that. We learned a lot, but we didn't turn into a product that we keep on. The next thing we did based on the experience we had there was to build a Python or active Python army. Armies are these machine images that you put up in Amazon Cloud. So the point of this thing we made was to provide a land stack that included active Python and various things we added to it to kind of make it easy to set it up with it and get it make it easy to manage multiple instances. Just that make it easy to deploy apps using Python, including Django and various databases and stuff like that. This was kind of a year ago, and we are not really thinking that we will update this that much anymore because it kind of taught us things about the system that we think that we really wanted to build, which is what we call Staccato, which is a PaaS system for private clouds. So the plan is then to provide this PaaS layer and as kind of finished components that you can install on your own machines, in your own cloud cluster if you have that, in your own organization. You can also put some of that on public infrastructure like Amazon. The point is that we don't plan to kind of host this thing, we just give you a solution to build your own path. So that's where we are now. While we were kind of moving towards this goal, VMware announced Cloud Foundry. It was early in May. We took a look at that. We saw things we liked there. We decided that we would actually move to base our system on kind of this code-based Cloud Foundry. Cloud Foundry is built in Ruby, so a lot of stuff in this space is Ruby-based, but we can live with that. What we did, we took the Cloud Foundry stuff, we spent resources on typing it up, packaging it up, so it's easy to install and play with. We added support for Perl and Python. And we packaged up and managed to make the first kind of preview of this available this week. So if you are interested, you can go to our site and kind of sign up and probably get an offer to test it. But it's still early. I mean, we have just been focusing a lot of effort in the company to do this kind of for 2 months based on the Cloud Foundry stuff. And we are talking to VMware and trying to kind of drive this forward and see where we can take it. It seems like a good starting point. So this part of the talk is going to be about kind of what we learned on our way to what was Staccato. So it's kind of our best practice as we see it, but it's not really hard rules here. It's perhaps more of an input discussion about what would be a best practice for cloud computing or using Python. And actually what is exactly best practice is not something fixed, it's kind of a moving target. What's best practice today is probably something else would not be the best practice sometimes in the future. So yeah, that's that. So we divided it into 6 parts. I'll go through that now. The first part is to keep things simple. Try to keep your apps simple. Use simple concepts. First good kind of rules. Try to use simple databases if you can get away with it instead of going the full way. Can you get away with a key value store? Just use it. We also think that LAMP stacks actually work pretty well. That's what we added to build both Firefly and on top of. LAMP stacks are basically also built in the Staccato thing. This shows what the LAMP stack or what parts we added to the army. Started out with the Ubuntu as another baseline level, the stable Ubuntu to be on the safe side. So MTS is the long-term support. They will support for 5 years. Use Nginx as kind of the front-end thing. And it stores static files and gives traffic back to the worker instances where we host the Python application. We host it on Apache with more. We use active Python because we like it. and we use ppm as the package manager to pull in packages as you need them. We also support pip in active Python, so you can use both, but ppm installs faster because it just puts down pre-compiled packages. We use virtual items so that you can isolate your pieces. You can run multiple apps on the same host and still have them isolated from each other. It's with Django and some databases. It was a year ago. With Staccato, we have a lot of things with us still, but yeah, what actually changed. Make it very simple to deploy apps is the second part of making things simple. Developers usually don't want to have to deal with all the sysadmin things about getting their stuff out. Just want to be in their ID, coding, checking things into version control, and then send it off to the client, and it should just work. Make sure that dependencies are installed automatically, so you can just say what you want and everything works. Manage packages, the package manager for the OS for kind of the big parts of the picture, and then use Python or Pip to manage Python packages. At that level, you can also kind of install multiple versions of the same package for different apps on the same machine. So you can kind of use OS packages at that level. Do you think it's a good idea to use pre-built package repositories like PyPM provides? Post data from a single, post packages from ActiveState's repository, single one. It's much faster to install that way. It kind of posts packages all over the network and often need to compile them on the fly. It's slower. But it works both ways. Second part is about keeping things isolated. I think I've been mentioning virtual language before, but yeah, the idea is to compartmentalize and isolate your different environments, so each app has their own environment. Use virtual language for that. Virtual language wrapper is also a good tool if your work style is kind of the way that you often switch between different environments and different apps. I usually just go with virtual language. Yeah, isolation is good because you can experiment freely without risking corrupting your other environments, and necessarily allows you to have incompatible versions installed for different apps on the same machine. Yeah.
Do you have a good solution for binary dependencies with virtual ends? It sometimes makes problems with it.
Yeah, well, with PyPM, usually kind of cheat a bit by statically linking those dependencies in the package we built. Software. So if you install MySQL, you have actually statically link it or use it.
But for Pip also, you don't have.
No, you then have to manage it by making sure that your build scripts install the right packages and then install the package stuff on top of it. And you do it in the right sequence. And if you have version incompatibilities there, then you have to, I'm not sure, you have to use different versions to make sure you treat apps that have different requirements for different machines. The other part of isolation is to use it to obtain security. You want to keep your different apps isolated in a way that corruption in one app or some security breach in one app, it doesn't corrupt other apps you might be hosting. Stage is Johanna, which is security researcher that has been talking a lot about these things. Kind of talks about how there are 3 ways to deal with security, either by correctness, which means that you try to make the code not have bugs, and not have ways to break into it, like SQL injection things and patching of things in that. The second one is isolation, where you kind of force isolated environments, so one code from something bad having one piece of code can't affect other stuff. The last one is obscurity, security by obscurity, which is where you kind of try to make it hard for apps to break a lot of stuff like randomization in the stack of limits and stuff like that. And everything can kind of, you want to do kind of all of this, but it's only kind of the isolation part of it that takes you all the way through. You still want correctness so that one app doesn't really affect that much. There's lots of ways to actually obtain this isolation for security. The safest one is to kind of give each app their own full virtual machine to run on. Usually that's quite expensive, so you might not want to do that. So there's usually search for some other solution. We haven't really come to the point where we have deployed it or put this into the product stuck out yet, so I think we are moving in the direction of LXC as the solution. Done. Next part is to just make things disposable. Basically, the cloud machines can suddenly go web, and you have to structure your things so that you can deal with that. It's a good way, anyways, to structure your code so that you can dispose of things that have turned back. So you set up the machine so that you kind of build them up from scratch from automatic scripts. And if you find something bad in the machine, you don't log into it and fix it up like you do traditionally and fix up the configuration and you live with it. You try to fix your build script so it doesn't have this bug, and then you throw away that instance that is bad and you do it over again. Fabric is a good way to handle this when you need to spread it out and make the build scripts that you set up the machines or different codes that you kind of get up. Having this build scripts also makes it much easier to handle software updates and alter configuration. Right.
Do you have experience with other tools like Chef or Puppet?
I think it's
Do you have any experience with tools like Chef and Puppet? That you've come across, and how would you compare them with Fabric?
Yeah, I think these tools are at totally different levels in kind of complexity in terms of dealing with large scale setups. We talk about Puppet, Chef. I know at the university we started using Puppet now, and kind of in the context of this thing we actually don't use that, and we are much smaller. And for the private cloud, I think the solution would be something similar.
Can I jump in for a second?
Yeah.
Puppet and Chef are I'd just like to clarify something. Puppet and Chef are tools that are for managing many machines on the level of preparing the machine itself. So they're conversion tools that describe the system state more intended for very, very similar machines, many of them. There's a certain amount of theory behind that, and this is more like you install hardware, you configure it, that's Puppet, and you deploy a service or application. That's the third level, that's what you're doing, that's what Fabric does. It's a different game.
So Fabric is basically just about SSHing into machine and making scripts run there to set things up. And it's a much simpler system. Yeah, and the fact that you have set up these build scripts is also kind of a starting point for scaling things up. Create lots of instances and replication and try to balance them over your different machines. You also have data that you need to deal with. Usually you don't want your data to be disposable, so you have to think about how you deal with data, how you persist it. Some data might be perfectly fine to be disposable, like caches and stuff like that, but generally you have to figure out the way of dealing with that, even on cloud infrastructure where the machine can go over. So you might not want to run your database exactly in cloud if you go with a traditional system. Or if you do it in the cloud, you want to kind of make sure that you learn stuff and set up hot placements that you can switch to if the main thing goes down. And you need to do backups. Make things relocatable is the next point. It's about making sure that the components you kind of build your system on can talk over the network and can live on different machines that still communicate. So you select things that talk over sockets, that talk over the network. It's a good idea to set up distinct host names early on, so that these host names that you call instead of more specific things about exactly how it is, how the instances are spread out when you start out. So you might start out by just having all these host names you allocated in your etc host file or in DNS, and then moving things around is just about configuring host names to point somewhere else. And especially your database and your web app, you want to make sure they are separated early on. Set some things for easy scaling and cloning and keep things portable. It's a good idea to not tie yourself too closely to a specific vendor. So it's a good idea to make sure that you can run your machines on different IIS levels. That's what we kind of use your cloud service for. It's good both to be able to move as you find a better deal somewhere else, and also when one of the vendors kind of goes down, it's good to have alternatives that makes your app stay up. When it comes to PaaS systems, you usually get much stronger ties because the PaaS systems have specific APIs you have to relate to and specific restrictions that you have to keep with. So, for example, like Google App Engine has very specific things that you have to code against this API that they provide. It's very hard to move off that platform afterwards. So you are kind of stuck with that. So perhaps it's a good idea to select some PaaS system that kind of uses standard framework like Gisle, and you can kind of program against an API that you know you can move many places. Minimize dependencies is similar. Dependencies on PaaS adoption or dependencies on specific components that might be hard to pull. And then it's a good idea to actually rely on web frameworks. They provide lots of abstractions that makes it easier to code your applications. talk. Okay. Yeah. So relying on web frameworks is the last one here. So it provides lots of abstractions that are useful for you to keep your app portable. Object relational mappers or RAMs, just part of the framework usually. Abstracts the database, makes it easy to move between different databases and also handles kind of it's easy to locate the database. Probably a database from that database, right? It's a good thing. Also, I think it's good to think about scalability early. Yeah. Perhaps it's a good idea. Totally sure. Depends on what your expectations about the app really is, but for many, perhaps you should get away with not thinking about this. So do cloud stuff because it kind of gives you an easy way to manage your software and not have to, as you said, in it. You run the cloud in a small scale too. But if you aim high, yeah, scalability is probably something you should think about. And the last one is that you should try to use open source software whenever you can. It's good. You go that way as often as we can. So I won't say much more about that. So in summary, these are kind of these rules we say you should live by. Keep things simple. The app and how you deploy it, keep things isolated so that the apps don't kind of use each other in bad ways. Just create things so that they are disposable. You can easily create new ones. Keep things relocatable. Think about portability. Keep your options open and use open source. So then I thought I would say something about this staccato thing. First by kind of saying how it kind of fits into this picture of these rules and best practices I talked about. First off, keeping things simple. That we can't really help you with, but deployment is really simple with staccato. It says here, it says three-step deployment thing, but the first two steps is basically just selecting the cloud where you want to put it, and then log into that cloud. And the third step is just push your code. And once you have done that once, you probably push to the same place every time. So, and it's just a one-step deployment thing. You just say push, and off it goes, and it comes up. Keep things isolated. The path solution kind of takes care of that. Make sure that each instance gets their own environment. We actually use virtual app underneath there, but at the path level, you don't have to care about that. And we also provide security. Yeah, it's not really there yet. Keep things disposable. Yeah, the virtual machines we provide are kind of disposable. You can just throw them away and add new ones to the cloud whenever you do that. And this push thing kind of makes sure that your code that you write is separate from the instances where it's hosted. Relocatable in the staccato thing or the cloud foundry thing. There's this concept of services where you know abstract databases and that. So that part is parallels. Code can relocate the databases. Portable, yeah, you can run this pass on different VMs or real hardware or on Amazon lambda stack within that. Lambda because actually the A is gone and it's only Nginx left. Below Archie, we just use the risky kind of. So if you grab the staccato, this is what you get. You get an image that is a virtual machine that you can just run. We call it a microcloud because in that image, as it's when you boot it up the first time, it kind of contains all components that makes up the cloud. And that's all running on the same machine. So that makes it easy to use it for testing how things work in this kind of cloud setting and experiment with it that way. But you can take this image and put it on different machines and then configure it to have specific roles so that one machine has some components, one machine has other components, and we can scale it up by having multiple machines having multiple instances of the same component. When you provide a client, a client there, it's just a small program that makes it that you use to talk to the cloud and to deploy your apps, control and monitor what's in there happening in the cloud. For the Cloud Foundry, they have a similar client called VMC. We found that we wanted to, it was best to actually rebuild this client over again so that you could get rid of the Ruby dependency that was in the client, and also to be able to extend it with additional things that we needed to add to make it feasible to run Python. One thing we added was the ability to run commands out like, for instance, for instance, in the general setting, we might want to run some commands to set up your databases and make that kind of work. We also plan on getting Komodo, be able to talk directly into the cloud, so you can do deployments directly from Komodo and get things to work and also see what's happening in the cloud from Komodo. This is also the entry point for the browser when it kind of talks to the apps inside the cloud. This is how it looks inside. The front end is Nginx, where all the traffic comes in. So this is the staccato from Nginx. It sends the traffic to a thing called the router, which is a process that kind of just looks at the header and then forwards it to the right instance, or select one instance when there are multiple instances that can do the same thing. When the staccato client talks, it kind of gets all the traffic routed to this cloud controller thing. The DAAs is kind of where your apps actually run. You usually scale this up by making lots of them so that you can handle more load. All of these components, they talk over a bus, or message queue service. The one that is used in Cloud Foundry now is called Nuts, which is a very simple Ruby-based message queue, but it will probably be replaced by something that's easier than people There is a health manager there that just watches the whole system and sees if something is bad, and it will kind of contact the cloud controller and tell it to kind of fix things. It's not DAAs that might have been died or something like that. And then at the bottom there is all the services. In the first installation, there is all these three services available. You can provide the databases, MySQL, Redis, and MongoDB. So that's kind of the system we have now. And we plan to kind of expand it in the future, add lots of new services and try to tighten it up so it's actually easy to use it to build across span lots of machines in your own organization. It just repeats how you actually use the thing. But I think if somebody is actually interested in seeing this, I can demo it later. It's best to find me and grab me and I'll show you. Otherwise, you can go to our website and download this thing after you have signed up. And, rest of there. Questions if there are?
So this may be a little bit naive, but why are you using Apache once you have Nginx?
We don't use Apache anymore. We used that in the Army solution, but now we just have Nginx and you basically to run the Python processes. And yeah.
Anybody else? I cannot see.
This is not quite a question, but just a comment on some of the slide material, which might be a little bit out of date. But regarding portability away from App Engine, you actually can write portable apps now. Because of Django non-rel, you can actually write a Django app and have that run on top of App Engine. So you can remove that between the App Engine stack or from a typical traditional hosting like Django. So there's no more vendor lock-in type of scenario with that. Yeah, just a comment.
And speaking of vendor lock-in then, is the whole active state, what's it, Staccato, open source and free for anyone to download, or does it cost money?
Well, it's very early, so we don't really know what it will be, but
And how do you avoid
some uses, so it will certainly cost money, and I guess that's the plan for.
But how do you avoid getting locked into Staccato then, for example?
Well, I mean, what it does is provide you a way of running Django in a standard way, so you are not locked in if you kind of, it's just a practical way of running Django apps in your own environment. So, yeah, you can always move off Staccato by just porting your Django apps to run in a traditional way, or you can also say that you are, well, you can move Staccato to a different infrastructure and stuff, then you just move the whole task with you and you are kind of locked into Staccato if you feel that it gives enough value that you want to move it to it, and yeah, sure. But we don't really provide that many APIs. There will be some kind of specifics about how you bind to the databases. So when you bind to a database, Staccato will kind of provide it. The names of the database you should use in library variables and stuff like that. So you will have code that kind of connects based on these environment variables here. But it's kind of at that level that you have binding.
Anybody else?
Do you have plans or does it already work also Zope as an environment? Because I think pyramids and Django per Zope, it's usually a little bit more difficult to make it run on a pure Python environment.
No, we don't, but you can basically run any Python code that you package up and then deploy it, but then you would need some solution to the database for it. And then basically we would have to provide the SODB as a service so that it can persist and stuff like that.
Okay, yes, there is also something that I think is not available in pure Python, that it must be compiled with Zope, also with the core of Zope.
Yeah, I'm not totally sure about the state of PyPM in terms of supporting the whole Zope stack, but I mean, it's not high up on the list of things people do, I think. So yeah, Postgres is kind of one of the biggest things people are asking to get support for early on. So currently we only need MySQL that's related to config.
Okay, we should have time for one more question. We're done? Okay, thank you.